Hi guys, good evening. Welcome again to one more episode of the Amiga Raytracing webcast. 43rd episode today, and we are going to talk about syncing animations with audio. Now, many of us, we create simple animations, we create some more complicated animations, but then we don't know how to create a multimedia out of it, meaning an audiovisual experience to show to others. Okay, sometimes we put some background audio, some new music, but with the hope that it will match and it will sync by itself, or just stop caring about that. Today I would like to show you how we can remedy that so that the experience will be more that it will show that the audio and the video can coexist and they can match to one another. So there are some ways to attack this problem. So let's get started right away. Let's see here. Let me fire up. So let's say I want to create an animation and I want to put the sound starting with a nice mod that I like, and I want to match its tempo. Okay, so I'll just start with by showing you what I've found. I found a very nice demo on Nominet. You might want to download it yourself. So it's called Pastel Pop. Okay. And so on and so on. Okay, so this particular demo, what I thought of doing with this is I want to find out what its tempo is, okay, and then I would like to step on that. I mean to based on its tempo to have an animation of a text that its credit will be changing according to its tempo. So if the music goes like that, let's do it once more. I will show you. So I have one transition here and then I have the other transition. So I'll show you what I want to do. So it's okay. So first of all, we have to know what its tempo will be. Okay. After that, we would want to translate that to frames, so that I render in Lightwave so many frames, followed by the next transition that will be so many frames. Okay. Let's start by finding out how many frames each meter of this tempo is. Okay. My thought process in the beginning when I was preparing this episode was like, okay, I'll go to ProTracker and load the demo here. Okay, no ST0. Load the tempo, and where's that? Mods, general, mod pastel. Okay, so this is the tempo. Okay, and I see here. No, wait a minute. Play. So I see here 137 BPM, and I will divide that by 60 to see how many beats per second I get, and then I will translate that to frames. So I sat yesterday and did so many you know so many calculations doing that, and okay, I came up with a number. So, or I came up with an equation, and I'll just write it down so that, you can experiment with. But it doesn't work. It's an approximate value. Okay. Unfortunately, it's not accurate. So, but anyway, I'll just type that in. Yeah, let me start Brilliance and type that here. So I'll just select this font and just write it down so that you can have it and you can play with that. Anyway, yeah, this one. So the equation goes like FPS times double parenthesis 60 divided by BPM, closing one parenthesis, divided by 4, and I'll tell you why. So this is the equation I got around with anyway. So what actually there should be something more, so I'll just put in the beginning positional frames, and I'll tell you what this is in a second. Okay, so let me delete that. Nice. So this is the positional frames. Okay. So positional frames. If you go to a tracker, let's say Pro Tracker, you will see position 0, 1, 2, 3, 4, 5, 6, 7. So every pattern has, let's say, 60 positions. So you have 4 tracks or 4 channels, and each one has 1, 2, 3, 4, 5, 6, 7, 8. So what this equation tries to do, it tries to find how many frames are equal to each position when the tracker transcendent plays a mod. Okay, so if I make an example out of that, let me say now, or let me make an example here. So let's say FPS. So we have 25 frames per second times 60, which is the seconds I want to divide some the BPM. So its BPM was 137. Closing a parenthesis, divided by, let me clean it up, divided by 4, which is a number I found. I found out that 4 positions are equivalent to 1 BPM in 1 beat in your BPM that is selected. Correct me if I'm wrong, guys, down in the comments after I publish the video, because I would like to know what is going on here, since it didn't always. I mean, it was approximate. It wasn't accurate. So I was expecting for my frames to, go like punch exactly where the transition was happening, the transition of the tempo, but it didn't. So if you know any more information about each position, how the Amiga is counting these in relation to time, to frames, VBL and so on, please let me know down in the comments, or send me an email or whatever. So back to our equation. I think this is correct. So that makes, let me fire up an external calculator and say, so I have 25 times 60 divided by 137 and divided by 4, and I have 2.737. 2.737. So back here, that equals to 2. Let's put a comma here. 737. Okay, so that is what I had in my example. So example, for that particular demo we are listening now. Okay, so here it is. I'll just hide that too. 1 minute. So I'll just hide that too, so that you will be able to see that. Okay. So what I found here, this number tells us how many frames should equal each positional each position that the tracker cursor meets, you know, going down, down, down. So if I want to say, if I measure my, hold on a minute, if I measure my demo, let me open Workbench because save. Great. So if I measure the demo, if I go, let's say if I go to Pro Tracker and I'm open that. No, sorry. This sound mods, general and pastel. Okay, so let's say I try to start and stop where the tempo changes. So for example, oops, sorry. Why? Somewhere here. So this is the second, you know, the bass lap that it shows, you know, this is position 32. So the tracker has transcended from position 0 to position 32. Okay. And there is where my music is like 1 meter, 4/4 as I hear it, and 1 meter of the score. So 2, 3, 4, stop. So 32. So it's 33 positions. Okay, so I know that is 33 positions. Okay, so I go back then to this result here, and I was like 33 positions times. Let me just 33 positions times 2,737. That equals to calculator again. So it's 90. It's 90.3.321. Okay, so 90.321 frames. Okay, so many frames. Let me do that. So there are 33 positions on the tracker times 2. Times this here. So let me just have this here. So this is 33 positions times 2.373 equals to 90.321 frames. So rounding down is 90 frames. So if I were to render 90 frames, so let's say I had one transition. Let me show you what I mean. One transition, and then after 90 frames, I have another transition. Let's say, text saying Muadib after 90 frames presents. That should fall exactly on the tempo of the music. But here's what's going on. I will show you the example I wanted to base this episode on. Okay, so let me save that actually for the patrons to have. Actually, yeah, it's in the video, but anyway, 3D and webcast. No, sorry, no. One moment, please. Here, and now is today's episode 43, and I'll just save that here. I can't anyway. Tracker frame equation. Okay, IFF. So there you have it. The result of that is what I'll just show it to you now. So I'll just add the animation that I did. So this is time attempt 1, so 25 frames per second, as we said. Oops, sorry, there. And then I can add the sound. Scala is an amazing program. I mean, that's no wonder why TV stations were using that. They were using it to base their whole their programs, transitions and stuff. And what I was going to do, yes, and go then and load the sound. So sound, mods, general, and pastel pop. Anyway, okay, and this is what I get. Okay, let me put it in full screen for you. So run. No, wait a minute. Take away the pause. I want them to start not at the same time. No audio because I think ProTracker is still on. Yes, sorry. ProTracker must go. Let me see. Yeah, nothing is here. So let's see. So this is a this transition did not go well. Then I went on and this was a 90 frame transition, so it should have been correct, but it's not. So then I did another attempt. So then you start cutting your frames so that it to see what is the exact figure really. So let me delete that. Number 1. Then I started, I think this has 85, if I'm not correctly, 85 frames per transition. And let's see what sorry. And so on and so on. Okay, so the numbers are not correct. So either I have latency or I have miscalculated something, or I don't know much about tracker. Probably the latter because and one more thing. Let me bring back the equation so that I can show you what I am talking about. The tracker frame equation here. So you may you will notice a 4 divided by 4 there on my equation. Okay, so it's like 60 divided by BPM of the module, and then all this is divided by 4. So now the 4 is what I found when I was playing a module at 60 BPM, okay, where, say, 60 BPM, you know that you have 1 BPS, 1 beat per second, okay. So when I played back the module I created, so that to count how many milliseconds was each position was advancing, so I found that it was 4. Okay, so I assumed that if you that 4 divided is something, you know, that these positions advance. So probably that's where the error is. But if you know something more about that, please let me know down in the comments. Anyway, so the other attempt, so instead of going this way, the other attempt was converting the module to a sample, and then using a sample editor that supports a timecode index, just read out the index that I was about to, you know, the index of the index where the sample would, you know, change a meter. Okay. So and I created this workflow here. So let me show you what I came up with. Okay. First of all, we go to Aminet, I browse, and we search for mod to WAV. Okay. So this is what we are looking for. Okay, this is a very nice converter from ProTracker modules to WAV, to WAVE, IFF, or RAW format. So when we download that, I've already done that anyway. Then we go to, okay, I'll just go to the subdirectory that I have the mod I am interested in. General here, so list. So this is here. It's mod pastel underscore pop. So if I play that, you know, let's say mod, how does that work? I mean, the help is very comprehensive. So it has an example here, whole song to wave. So input mod, output wave. So if you just replace that with output IFF, which I'm going to do right now. So see mod, what was the mod again? Pastel. Okay, I will do another one because I've already done that. So as you can see here, pastel pop IFF. So SLE mod. Okay, so I'll just say SLE IFF. Is this correct? Yes. So I'll just click press enter, and then, you know, I have my sample, my module as a sample now. Okay, which is here, SLE IFF. Okay. Now all I need to do is a sample editor that can tell me at what time code is the specific event that I want to, you know, I want to find the duration of a specific event. In this case, I want to find the tempo of the music in frames. Okay, so then my search gave out this program, Samplitude Opus. Okay, a very, very powerful I'll just run this one, Samplitude 060. Sorry, it was there. Execute. That can do lots of stuff. Unfortunately, I'm not that strong with sampling and etc. But I found out how to use that to learn the time coding. You know, to be able to know, okay, at what event is how many frames, or how many what's the time is at that event, at that particular event of the sample. So I'll just open the sample. My friend here. Anyway, MISC, sound, mods, general. I'll just load the Pastel Pop IFF. Okay, RAM type, and if I play, okay, so that's it. And what I'm doing is I'll just zoom in, and now the keyboard, you can see the keyboard layout here. What I want is for it to stop at current position, not stop and go back to the beginning. Okay, and I'm gonna just test it. So space first, and then shift space for it to there, and it stopped there. Okay, now all I get here is a number, which is, I think this is samples. Okay, but what I want, I go to preferences, and I see units here. I want to the SMPT timecode. Then it starts to ask me at what frame rate, and it has 3 presets, but I think I can put some more. And then I choose 25. Okay, 25. Then I get a number here, another type of number. Okay, so SMPT is a standard for time coding where you have frames here, and then you have seconds, and then you have minutes, and so on. So this gets up to 24. So counting 0, you have 25 frames here before it advances to 0, 1. Okay, so if I go to the beginning, 0, perhaps. Sorry. There. No, sorry. Let me zoom in. There. So start. Now that's a range. Let me see how does show beginning of sound. Yes. And how do I take them? Do I have to? Yeah. Anyway, here. So shift space to stop. Okay. And I want to find the beat. I want to find the BPM. So there. And then I read out this one. 303. So this is 3 seconds and 3 actually it's 4 frames because we have 0 0 also to account for. So we have 4 frames here and 75 frames here, since this is 3 seconds. Okay, so this is 75 plus 4, 79. We have 79 frames. That's strange because, yeah, that was almost there really when my second approximation. So 79 frames. Okay, now that we know that, we can create a very easy transition from text to text. We're closing that. We're closing that and then go to Lightwave. Okay, to layout, and I have these 2 objects here that I thought of doing this. Okay, let me load this in. So this is timing attempt. Sorry, oops. Loading. and episode 43, and no, sorry, I think I'm a bit stressed here, but there's no need to be stressed. Why am I stressed? Anyway, so I have 1, 2, 1, 2, as you saw. Okay. We said 79 frames. Okay, so let us fix the timing then. Or let me start from the beginning. So clear all objects. Okay, so I'm loading my 2 objects. And object 2. Okay, so this can be whatever, like say yours truly presents and a video that became a blockbuster. Okay, so number 1. Now we're going to be messing with the object dissolve envelope. Okay, and we can do it like this. So at 0% the object is totally visible. Okay, so we want based on our 70 frames meter that our module have, we want each object to transit each other at 79 frame interval. So I want that 79 frames visible. Okay, and so since we start at 0, let's start at 1. Keep it as Lightwave wants. Let's start at 1. So at 79, that should be the last frame that my object shall be visible, and at 80 I am pressing N and put it at 100% dissolved. Okay, now I see some non-linearization here, but I can fix that by pressing S linear and again S linear, and I'll show you why. Okay, so at 80 this is invisible. Okay, so 80 times 2 will start being visible at 160. So 159 shall be the last frame that it is invisible. Okay. Now the reason I did that as linear, even if it doesn't have any importance here, is because the next frame, the next keyframe I'm going to be creating, it will adopt this keyframe's spline control options. Okay, so you see now I haven't pressed linear here, but it adopted it from its previous keyframe. Okay, so that's one thing to consider when you do changes before you create the next keyframe. It will adopt the next ones. So let me do anyway. No, let me do nothing more. So 159, then I'm doing something else. Having this one here active, I'm pressing 180. Oops, sorry, 160. Deleting that, 160. There. Okay, so that adopted its active keyframe value as well. So you can have these in mind when messing with, when creating motions here. So, okay. So here this is visible. When time comes here, this is invisible. So we need once more for that to be visible. So that will be 160 plus 80, 239. Last visible, and then 240 here. Okay, 240 plus 80, that is 360. No, wait. 240 plus 80, 60, 320. 320. So that shall be 319. Okay. and that shall be, no, sorry, and that shall be 320. And that concludes the animation, the dissolve behavior of 1. Okay. Let me save that envelope, temporarily, use that, and go to 2 here, pressing envelope, loading the envelope I saved. That's exactly, this is the envelope from 1, and just change the values for these, just invert the values. Unfortunately, I can't do that automatically, so I'll just press N to every keyframe, N, and 0, 0, 100, 100, 0, 0, 100. So let's see what we did. 0 up to 79, this is invisible. Starts getting visible at 80. 170, 159, 160, 239, 240, 230, 320. Now, what did we say? Let us go through all the data that we have. So we said 79 frames per transition, correct? Yes. Keyframing starts at 1. So 1 plus 79 is 80. So it may seem now that I may fall behind instead of in front, but let's try that using envelope, saving that transition timing attempt 2, and we will record these 24-bit frames here as the output test. Let's test that. It will overwrite everything, but that's okay, we don't care. Save that again. Everything is okay. I don't need any anti-aliasing yet. I'm making, I'm doing some. And also I would like to activate that overlay and write here frame. So what this does, I'll show you what this does. That creates an overlay here, so frame 0, so that I will know what is my frame. Okay, let me see, all set. Frame, data overlay, correct. Let me save that, timing attempt, yes. Now it's asking me if I want to, no, I don't want that. And also I am deactivating that. And I'm pressing enter. That was going to be very, very, wait a minute, what's going on here? 1 to 360. Frame step 1, 25 frames per second. Timing attempt, no. So 1 to 360, automatic, no anti-aliasing, no render display, saving images, on and go. So you can see, last frame. So we're waiting a bit. At the same time, I can prepare some other stuff here while Lightwave is doing its thing. So we are going to be needing a new output. So I'll just delete that, all these old frames. This is output R. This is output rendered. So this is the output from Lightwave output, and then another subdirectory called output R. There are we going to be having my rendered output. So from IFF24 to HAM8 images. Okay. Perhaps I should have done that. No, anyway, it's better to have control. So yeah. Oh, Lightwave is already done. So I'll just quit that and select all files here. So I have, actually, I don't need that. I'm removing this. So I have 360 from 1 to 360, correct? I am opening commands so that, you know, I have a load, I have a render, and I have save rendered. So I'm beginning the conversion. So I'll just have to point webcast 43 output R. So I want them here. I want them loaded here. So it start to do that. So yeah. So such, you know, this kind of work is it's very fun to have it on an emulator when you can boost the speed, you know, as much as you want. There are some mishaps in with the FSUA. Sometimes the image effects crashes while doing that, because maybe it's too fast for the file system to write to, you know, I don't know. So, but some other times it just fares just fine. Anyway, I have another instance of this. If you want to do stuff like that, it's better to have an instance where you have a high accuracy setting, so that it's slower, but it won't have the risk of crashing. Okay, so fortunately for us, it went well. So I'll just quit that and go to Scala there, and going to System AnimLab, and I'll just make an animation here of based on these rendered. Wait a minute, webcast. Oh, the mouse wheel doesn't work with Scala. Output, anyway, 360 files here, 260, and saving that as timing attempt 3. That doesn't correspond with the scene naming, but anyway. Or perhaps let's make it 2 and delete number 2 because we don't need that. Where's my animations here? So timing attempt 2, delete, bye-bye, and just be nice with that. There. So 360 selected, saving an animate long word and no Floyd Steinberg and no palette optimization because it's ham already. So execute. So here again, anims and time attempt 25, and then we add some sound, load the music from I can very well load the IFF as well, but it's not that good of a. We can try that later. By the way, for comparison, see the sizes. Anyway, there, and let's see what we've done so far. So let me see. No pause. So let's see how that fares. it needs one frame per transition, so we have to redo that. So I think 79 was, let's say 78 frames. Okay, so let's do it once more and hope that nothing bad happens to us or the emulator. So I'm just deleting that and go to Lightwave again, load the scene, episode 43 there, timing attempt 2. So now we are going to edit again, not the motion graph. We're going to edit the envelopes for dissolving. So what I want to do is I want to bring one frame. I want to bring one frame earlier the transitioning here. So how would I do that? I could very well, okay, say, -1, but we can, there is the shift key tool here. So we can do that as well. So let's say I want from 79, shift keyframes by -1. Let's see what's that there. So this and this transition is okay. Now this transition, so I'm just, cutting a frame from here, then I will cut a frame from here, and I will cut a frame from here, and so on, because right now I just cut one frame from this transition. Okay, so now I want 158 and on. So, and yes, going on there, 237, shift frames by -1, sorry, -1. And I think this also is last, 316. So that should be 300. Hold on a minute. Yeah, 316 -1. So yes, okay, so we're saving that. Yes, that's a temporary envelope name, and we're going to number 2 here and load envelope. Now these transitions are correct. The only thing that we have to change is the values. So numeric 0 0 numeric, oh sorry, 100 0 0, and we're done. 360. This ends in 462. Okay, so once more and save that as timing attempt 3. No, don't change that. No record, saving RGB images. That they should be overwritten. And just wait a minute. Let me delete these as well. So yeah, yep, great. And then render that 1 to 360 there. Now there's a faster way to do that, really. Okay, I don't have to render the same frame over and over again. So it's just a waste of computing energy. But let's do it properly. Let's say that you had other things going on up to these transitions, which is more yeah, it's more usual. But if I want to avoid this, I'll just how should I do that? Yeah, there was a faster way, but yeah, you have to render this so that the animation has to be, it should have these numbers as well. But anyway, yeah, what I was thinking of doing was like, okay, just naming the first and the 79th, and then the 8th, the 80th, and then keeping the gap, and then you would have, you would go to effects, but let's not, anyway, sorry for, you know, messing all this around. Anyway, quitting that, we have saved, yes, we have done that, and going to image effects once more, auto effects. It has saved everything from last, since the last project. So TIFF to anim, TIFF to IFF, and let me verify that. Yes, output R. There. Cross your fingers that it won't, or horn your fingers, whatever you want, so that it won't crash. Anyway, by the way, let me see, is there anyone out there? Yeah, hey, Amiga Ireland, another TV viewer, Girly and Space D. Hi guys, thank you for being here. Hope I'm not too boring tonight. But anyway, there are some things that we should tackle actually. If you think about it, sometimes the audio, hi Yarla, sometimes the audio is more important context-wise. You know, imagine instead of listening, you know, you listen to a radio very, very easily. You know, you can listen a theater presentation, you know, or whatever. But how easy is it to listen to watch TV without sound? You know, the audio is very powerful as a means, so we shouldn't underrate that. Should be always aware of that. So what I do now, yes, now I'll go to System, Amiga, Anim Lab, Animation, Optimizing, Floyd Steinberg, nothing, Show Rendering, no. Sorry, I'm thinking aloud here now, it helps me concentrate. Webcast, 43, are all 360, test, anims, and timing attempt 3. There. Okay, let's see. Amazing program, Animalab. There. So let us take the file system. You think it's organized? Come on, man. So timing attempt 3, 25 frames per second, and no pause. And sound, we want the module. Where was the module again? Sound, mods, general, mod, pastel, pop. So let's see what we did. It starts from the beginning, but it went closer. So let me see, what can we do? Is there anything? So I think it's 77, really. Not 79, no 78, unless it's the latency from the emulation. So I really have to test this on real hardware, but anyway, we don't have the time just now. Before we close, I want to show you one more thing. We can do all this externally, really. even more accurately. Let me quit that. I will quit. Let me quit. Yeah, and show you here. This is first of all, you can find. Let me see. You can find Samplitude Opus in the Amiga Future, in this Amiga Future page. Actually, you can, I just Googled it, Samplitude Opus Amiga, and you can find several threads. EAB has some threads about that. You can find it here. So if you're a purist and you want to, to do all this work on the Amiga, which it's kind of fun, especially on real hardware that you are certain that is, timed. You can download that and give it a try. Right now the download button it's not here, but I'll just, yeah, here it is. Okay, so if you can see it, you can see, you can see the mouse pointer. Yeah, great. So closing that, there's also Audacity. Audacity is a very powerful sample editor, and you can do multi-track recording with that on Linux, Windows, and Mac. Okay, so having converted the mod to a sample, you can load it up here. So you can open that as a sample in Audacity. So let's go to here and then sound, mods, general, and then you have the pastel pop IFF. Okay, Audacity loads IFF. Yes, it's an amazing program. So this is our mod converted to sample. Let's hear it. Okay. So let me. How do you? Anyway, so if I zoom in here, and let me see, where is? I've forgotten it. Anyway, cancel. So if I go in here and say I'm zooming in there, so it will zoom in on this range I've selected. Okay, so if I, there it is. Okay, so here I think it was, there it is. So I'll just zoom in once more. There it is. So I'm keeping it here, and now I have to find the section where it says time code. So this is the time code, I think. Audio position, starter net of selection. So I have a selection here which has no thickness. So it says hour, minute, and 99 seconds. So it's on millisecond thing. So if you press here, or let's say audio position, okay, because we have no range selected. If you press here, you have all sorts of time coding formats. So this is what we are looking for: hour, minute, seconds, and PAL frames, 25 FPS. Okay, so, or even better, PAL frames. And you get 73 frames. Okay, so even if I tried to do that with the Samplitude Opus, it wasn't accurate enough. So this is 73 frames, really. Let's say 75, but anyway, yeah. Let me see. See here. So this is 0 frames. Damn, how do I do How do I do the transport here? Playing, transport, play, stop and set cursor. Aha, this is X. So X is a very useful thing to do. So let's do that. Aha, 77. But anyway, this is, anyway. 77 frames. Yeah, maybe it's accurate anyway. But perhaps it's the hardware. So yeah, take it with a grain of salt. So yeah. Anyway, so that was it for tonight. I hope you enjoyed that. Do I have anything else to add? No, I don't think so. Do you guys have anything else to add? Any questions? Any suggestions? Of course, feel free to drop me a comment down in the comment section. Thank you so much, Jarla. I really appreciate that you're here, and you know, sometimes it's very hard for people to participate, and sometimes it's really hard for me to do the show. But yeah, thanks to my wife that is supportive, and it's helping me throughout this. So if you have any questions, comments down on the comment in the comment section on YouTube. Email, you can mail me here, muadib3d at gmail.com. As always, you can support the show either on Patreon or in one-time support contributions, and the link is down in the description. But most of all, keep rendering, keep trying, keep ray tracing, keep creating, because there are so many shows about, people watch other people playing, and of course that is recreation, but we have to balance that with creating ourselves, and showing our friends what we can do, and especially showing what our Amigas can do. Anyway, last but not least, shout out to all our supporters. Jarla, which is here tonight. Anthony Jarvis, mid one. George Chocanos Volquero, GS, and how many did I say? So this is Jarla, Anthony Jarvis, GS, George Chocanos Volquero, and mid one. So yeah, 5. There are 5. And thank you so much. Thank you for being here, and take care, and see you next week. Bye bye.